Hello dear friends, welcome to a lecture of geometry. In this lecture we shall start the study of the next chapter, that is the sphere. Earlier we have studied two chapters, the plane and the right line. So from today we will start, from this lecture we shall start the chapter of sphere. I have written definition of a sphere here, which is simple to understand. The definition is: a sphere is the locus of a point which remains at a constant distance from a fixed point. It is a similar concept to circle in two dimension. Circle is locus of a point in a plane which remains at a constant distance from a fixed point. Here it is a locus of point which remains at a constant distance from a fixed point in three dimension, and the constant distance is called radius, and the fixed point is called the center of the sphere. So here the fixed point, the constant distance is called the radius, and the fixed point the center of the sphere. Now we shall obtain equation of a sphere. We shall suppose C is the center. I shall draw a figure here. Suppose this is the sphere, and this we shall consider as center of the sphere, and the radius, this is the center of the sphere. We will suppose the coordinates as ABC, and this is the fixed point. Fixed point is the center, and the constant distance we shall denote by this point, this segment, that is R. This constant distance is R. We shall consider a point P x y z on the sphere. Now again see the definition. Sphere is locus, or that locus means set of point which satisfies certain geometrical condition, which remains at a fixed distance. That means the set of points which remains at a fixed distance from this, the fixed point is center and the fixed distance is radius. So all those points which remains at a fixed distance from the center, and that forms a sphere. But see, this is three-dimensional concept and not two-dimensional. That means this is a sphere. It's a solid object like a football, you may imagine, and or otherwise we can consider this as this is the sphere. And now we shall obtain equation of sphere. For that purpose we have considered two things we have to consider, that is fixed point which is center, and then radius. We have taken the center as C, denoted by C, and the coordinates of center as ABC. So let C, A comma B comma C be the center, and R be the radius of the sphere. Further, let P x y z be a point on the sphere. So to obtain the equation of sphere, we should have to consider a general point on the surface, that is on the sphere, and we have taken that point as x y z. Now what is the geometrical condition? By definition, the distance between the fixed point and the point, any point on the surface or sphere, remains constant, and that is R. So therefore CP distance is R. We have Cp is equal to R, or in that this distance can be written as distance Cp square is equal to R square, and we simply use the distance formula. By distance formula we have see the points C and P. So we write the distance in square form, and therefore it will be x minus a whole square plus y minus b whole square plus distance formula in 3 dimensions, z minus c whole square is equal to r square. Actually, this is the equation of sphere in center radius form, where the center is given as a, b, c. Coordinates of the center are a, b, c, and the radius is r. So this is the equation of sphere. Of the sphere in center radius form. So we have studied circle earlier. What is the difference between the figure of our object circle and sphere? Circle is in 2 dimension and sphere is 3 dimension of object. So in equation of circle there will be 2 coordinates x and y. Z coordinate will not be there. And if you consider for circle, the center will be a comma b and radius is r, then the equation, this term will not be there. Then the equation will be x minus a whole square plus y minus b whole square is equal to r square. And in the sphere there is the third dimension or third coordinate is there, that is z. So z minus c whole square is equal to r square. Now we further simplify this equation and put this equation in expanding that equation in second degree equation, or therefore further this can be written as, so that is further we have, or next we have from this equation, suppose this as 1, we have from 1, expanding that. I shall expand this and I shall write the square term of x, square term of y and square term of z first. That will be x square plus y square plus z square. Now I shall write the middle term of each square. What is the middle term here? Minus 2a into x, minus 2ax, and then I shall write the middle term of this, which will be minus 2by, and next the middle term of the third square is minus 2cz, and further the square terms of each square, that is a square, that these are ABC are constant, which are the coordinates of center, a plus a square plus b square plus c square, and the right side is r square. So it is plus a square plus b square plus c square, and the right side, this term I shall write on the left side, that is minus r square is equal to 0. Now if I write this term in bracket, then that will be a constant term, and this is the general form of equation of sphere, or I shall write the last term as plus a square plus b square plus c square minus r square is equal to 0. So this is the, now we observe, this is the expanded form of the equation 1, and now we observe that this is the second degree equation. What are the characteristics of this equation that we should note? This is the second degree equation in x, y, z, which is first second degree equation in x, y, z, and second thing is the coefficients of x square, y square and z square are equal. Coefficients of x square, y square, z square are equal. And third thing we may note as, these are the characteristic of equation of a sphere. The product term is absent, that is term of x, y, y, z and z x are absent. The product terms are absent. X, y, y, z, z x are absent. So these are the characteristics of equation of a circle. So, equation of this type will represent a circle. Second degree equation in x, y, z, coefficients of x square, y square, z square must be equal and product terms are absent. This type of terms are absent. Then that equation will represent equation of sphere. Now, we shall prove that part, that is the converse part. So, this is the center radius form of equation of a sphere that can be written in this form, and if your center is given and radius is given, we first express the equation in this form. So, this is the first important form of equation of sphere. Now, we shall obtain the general form of equation of sphere, and for that purpose we consider the equation as a converse part. Conversely, we shall suppose the equation is conversely we take equation having these characteristic. We consider the equation. What is the characteristic? Second degree equation, and having coefficients equal. May not be, it is not necessary that the coefficients are all 1, but the coefficients must be equal. We consider the equation, and I shall consider ax square plus a y square plus a z square, and here you see this condition is satisfied. The coefficients are equal. The coefficients of x square, y square, z square is taken as a plus 2, I shall take 2 u dash x plus 2 v dash y plus 2 w dash z plus d dash is equal to 0, or d prime is equal to 0. So, where this is the second degree equation in x, y, z, because the degree of this means power of x, y, z, maximum power is 2, and therefore, the equation is second degree equation. Coefficients are equal, and we have not considered the product term. Term of x, y is not there. Then the square terms, and then the terms of x, y, and z. We have taken the coefficients as 2 u prime, 2 v prime, 2 w prime, and the constant we have taken as d prime or d dash. So, this is the equation, and we shall show that this equation represents a sphere. And to get the equation of a sphere, we consider the equation in this form. We express the equation in equation 1 form, which is center radius form, and for that purpose where a is not equal to 0. If a is 0, then the equation will not be of circle, because all the 3 terms will be 0, and the equation is first degree, will become first degree equation. So, a is not equal to 0. So, dividing by a to this equation, or I shall write this as second equation, dividing by a, we get. Now, see, this will be x square plus y square plus z square plus 2 u dash upon a into x plus 2 v dash or v prime upon a into y plus 2 w prime divided by a into z plus d prime divided by a is equal to 0. Now, we shall express this in the first form, means we have written like this: x minus a whole square plus etc., y minus b, and this form. We convert this equation in this form, and for that purpose we want to express each term of x in the complete square form, term of y and term of z also in complete square form, and for that purpose we collect the terms of x. See, that is, this is x square plus 2 u prime divided by a into x, and plus these are the terms of x, plus we add a third term to this. Now, what is the third term for this? For we have a square plus 2a into b, plus third term is b square, that means square of this term, and here this term we have considered as 2 into x, and we shall square this, square of u prime divided by a, or that is u prime square divided by a square, and then this will become a perfect square. So, it will be now square of using this formula, this will be square of x plus u prime divided by a, square of this, or x plus u dash divided by a it's a square, plus we have added the term, or we have collected the terms, or first I shall write this and then we will add the third term. So I shall write this term and this term, plus next is y square plus 2 v prime divided by a into y plus z square plus 2 w prime divided by a into z, and plus the remaining term is d prime divided by a, and that term I shall write on the right side with negative sign, minus d prime upon a. So we have only arranged the terms, grouped the terms. X term I have written first, then term of y I have written in second bracket, terms of z I have written in third bracket, and this term I have transferred on the right side. Now we will add the third term to each bracket, or this can be written as x square plus 2 u prime divided by a into x, plus now the third term is a square of this, that is u prime square divided by a square. So thus we have added this term by the formula. How to get the third term? That means divide the middle term's coefficient of x by 2, we will get this u dash upon a, and square of that is the third term. Similarly, we add the third term to this bracket, which will be y square plus 2 v prime upon a into y plus square of v prime upon a, that is v square v dash square divided by a square, and plus in the third term also we shall add, in the third bracket also we shall add the third term, so as to make it a complete square, plus this is multiplied by z plus w prime square divided by a square. And now the same terms are to be added on the right side. We have added these terms, these third term in each bracket on the left side, which was not here, and therefore we have to add these terms on the right side also. So the equation will remain as it is, or balanced, and thus if you add these terms on the right side, then it will be see the terms added, u prime square divided by a square plus v prime square divided by w square plus that is a square divided by a square plus, and this is w prime square divided by a square minus d dash divided by a. See, this is the term on the right. Now the left side will be, the left side is, or this can be written as x plus, see this is square of x plus u prime upon a. You can verify this using the formula of a plus b whole square. X square, the middle term is plus 2 times u prime divided by a into x plus u prime square divided by a square, and similarly the second will be, second is y plus v prime divided by a whole square, and plus z plus, that is w prime divided by a whole square. And right side is, right side can also be written in square form, and that we will write, or we will first write it as u prime square plus v prime square plus w prime square minus, and we want to take the LCM as a square, and therefore we have to multiply the last term by a into d prime divided by a square. So, or this further we can write as see, this will be x minus u prime upon a whole square plus, this is, we are writing this minus sign purposefully because we want to express this in the center radius form, so that we will get, comparing this with the first equation, we shall get the coordinates of the center and also the radius. So this is a plus sign, we have written minus of minus, that is the same plus, and the second bracket I shall write y minus v prime upon a whole square, and the third term I shall write plus z minus, that is minus w prime divided by a whole square, and the right side I shall write under root of this u prime plus u prime square plus v prime square plus w prime square minus a into d prime divided by a whole square. You see. Now comparing this with equation 1, we get this represents a sphere. Or what the left side will be? Left side is the distance, square of distance of the variable point x, y, z from the fixed point minus u prime upon a minus v prime upon a minus w prime upon a. So comparing this with equation 1, which is center radius form. What was equation 1? We have written earlier, that is x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. Now what is the value of a? Here the center is a comma b comma c, and what are these values here? A is minus u prime divided by a, this is x minus a, this value is a, this value is b, and this value is c. And therefore comparing this with equation 1, we get see the last equation represents, so equation 2 represents a sphere with center. What is the center of the sphere? Center is equal to, now coordinates of this center will be here a, b, c are the center's coordinate, and in place of a the values here are minus u dash divided by a, comma minus v dash divided by b, and minus w dash or w prime divided not b, but it is the same as a, and this is w prime minus w prime divided by a. This is the center. And what is the radius? Radius, see, r square means r is this value, and radius is equal to under root of u prime square plus v prime square plus w prime square minus a into d prime divided by a, and that we will write absolute value. So it is under quantity, and this must be positive because it is a distance, and which is radius, and that is positive. So where this is positive quantity, minus a d dash is greater than 0, greater than or equal to 0. If it is equal to 0, then the radius will be 0 and we will get a point circle, and if it is less than 0, then we will get imaginary sphere. If it is equal to 0, we will get a point sphere, and if the radius is less than, see, this quantity, under root quantity is less than 0, then we will get imaginary sphere. So this is greater than 0, and thus this is the equation of circle, second degree equation, and its center is this one, and radius is given by the expression. So what was the equation we have considered? We have written this as second. Now we shall consider general equation of sphere. General equation of sphere. See, for that purpose we write the equation of sphere. The equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Now this equation represents a sphere because it is similar to the equation that we have considered here. So what we have written the center and radius of which equation? We have written the equation here as ax square plus ay square plus az square plus 2u prime x plus 2v prime y plus 2w prime z plus d prime is equal to 0. So for this equation, it is a sphere with center is a sphere with center as this one and radius is this expression. So what will be this? Now what is that? It is a special case. This equation is a special case of this equation where a is equal to 1 and in place of u prime we have u, in place of v prime we have v, and in place of w prime we have w, in place of d prime we have d. So is a sphere represents a sphere with center is equal to. Now what will be the center's coordinate? See, compare that equation with this. In place of u prime, here we have u. So I have written there as a u prime, v prime, w prime purposefully because we finally want to convert the equation. To avoid the overlapping of coefficients, I have written this as u, v, w and this as u prime, v prime, w prime, d prime, or u dash, v dash, w dash, d dash. And now we have the center here. A is 1. For this equation, a is 1 and therefore this and u prime is u. So therefore the center's coordinate will be minus u and x coordinate minus u and y coordinate will be minus v and z coordinate will be minus w because a is 1 and in place of u dash, v dash, w dash, here we have u, v, w and radius is equal to. Now what will be the radius? Under root of. Here a is 1, so denominator is 1 and the numerator will be in place of these prime notations we have u, v, w and d. So this will be u square plus v square plus w square minus d is the radius. So therefore this equation is known as general equation of sphere, which is similar to the earlier equation and special case. This equation is special case of this. We have earlier shown that this represents a sphere and therefore this will also represent a sphere because it is a special case of this equation in which a is 1 and u prime, v prime, w prime are u, v, w and d prime is d. So changing this, so we are writing a is 1 and u dash, v dash, w dash as u, v, w. Similar to the equation expression for the radius, we have written this. So thus this equation we shall denote it by 3. Equation 3 is known as the general form of equation of sphere. General form of equation of a sphere, and we should remember this is the general equation of sphere and with center is this one, radius is 1. Actually this is the more general form is to be converted into general form. And how to convert this more general form to general form? Dividing by a. We have written actually this x square plus y square plus z square plus 2u prime by a, and that we have taken as u, and plus 2 v prime upon a y plus 2 w prime upon a and plus d prime upon a, and this we have named as u, v here and w and this last term as d. So thus this is the equation of general equation we will consider of sphere, and from that we can write the center's coordinate and radius easily. Now one example can be taken as like this. Find the center and radius of the sphere. I shall write the equation of sphere as 2x square plus 2y square plus 2z square. Coefficients of x square, y square, z square must be equal, and that I have considered as 2. And next I shall write minus 4x plus 8y and plus 10z and plus say 12 is equal to 0. Now see, this equation first we shall convert in this form. This is the equation that is more general form, earlier we have seen, and that can be written as dividing by 2. Dividing by 2, we have the equation becomes x square plus y square plus z square minus 2x plus 4y plus 5z and plus 6 is equal to 0. And comparing this with the equation 3, comparing it with 3, we get what is u. See, 2u is minus 2, 2u is minus 2, 2v is 4 and 2w is 5 and d is equal to 6. And from this, what is u? U is minus 1, v is 2 and w is 5 by 2 and d is the same. So therefore, what will be the center of this? And thus its center will be, therefore its center is C is equal to minus u minus v minus w. Minus u means 1. Take negative of this. Minus v is minus 2 and minus w is minus 5 by 2. And radius is obtained in this expression. That is, after writing the center's coordinate, now we shall square it. Actually minus u square is same as u square. So we simply square it, and that is or actually you can, or you say this is u. So minus 1 square plus 2 square u square plus v square plus w square, and that w square is 5 by 2 square minus d, and you see minus d is 6. So minus 6, and simplifying this we will get the radius as, so it is 1 plus 4, that is 5, 5 plus 6 minus 6, that is minus 1, 5 minus 6 minus 1 and plus 25 divided by 4, square of this. And if you take the LCM as 4, this will be minus 4 plus 25, that is 21 divided by 4, and square root of this 21 divided by 4, that is root 21 divided by 2 is the radius of the sphere, and this is the center and this is the radius. Or we can, observing the equation of the sphere in general form, when the coefficients are 1, after converting the coefficients of 1, of x square, y square, z square, if these are not 1, then divide by 2, they will be 1, and then the equation converts in this form. And once the equation is converted in this third form, now we directly write the center's coordinate by divide the coefficient of x, which is 2a, by minus 2, and that we will get minus u. And similarly divide the coefficients of x, y, z by minus 2, that gives the direct coordinates of the center. So thus, if you see here, divide the coefficient of x by minus 2, we will get 1 as the center's coordinate. Divide the coefficient of y by minus 2, we will get minus 2 as y coordinate, and divide the coefficient of z by minus 2, we will get minus 5 by 2 as the center's coordinate. And once the center is obtained, we square it. The square of this is 1, that is 1, plus square of minus 2 is 4. So 1 plus 4, and a square of this term, that is 25 by 4 and subtract d, and so thus under root of this quantity is this one, and that gives the radius. So in this way we can obtain the center and radius using these formulae when the equation of sphere is given in general form. So thus in this lecture we have studied two important forms of equation of sphere, which is center radius form and which is the general form. So this we have to remember as formulae. If the equation is given in general form, the center and radius is obtained by these formulae. So the remaining part we shall study in our next lecture. Thank you for watching the lecture.